Welcome back to the latest episode of Naruto DX Battle Monster Minion Mode Extreme. Just kidding. We're doing pointer, pattern, fast, and slow pointers. So given the head of a singly linked list, write a method to check if the linked list is a palindrome or not. A palindrome, like race car, or no rats live on no evil star. Shoutouts to grade 5. Your algorithm should use constant space, and the input linked list should be in the original form once the algorithm is finished. The algorithm should have O(n) time complexity, where n is the number of nodes in the linked list. A fast and a slow pointer to solve this. So what if I found the middle node, as we did in the last problem, middle of the linked list. So I find the middle of the linked list. What do I do once I find the middle? 2, 3, 4, 5. Or 1, 2, 3, 4, 5, 6. So if I'm on the right middle value, then I would move my 2 pointers would be here and here. So I would put a pointer on the left of this one. Wait, but I can't go backwards. In a linked list? Huh. Can't go backwards. So how would that work? Could I do anything if I know about the middle value? Constant space. So constant space means I can't make any data structures, correct? Let's just verify what constant space means. Oh my god, load, dude, come on, let's go. What if you... The amount of space is independent of the input parameters. Say you are given an array of size n. If the amount of space your algorithm uses scales with n, then it is not constant. If your algorithm uses a fixed space, then you're golden. Memory does not depend on the size of the input. When you use recursion, the stack is also counted. Okay. Dude, but like... Okay, how do I friggin' start this thing then? If palindrome, because I could get the middle, and then what would getting the middle do for me? I could get an array, and I could save 2 arrays, the first half and the second half, and see if those 2 arrays are reverse of each other. But maybe that's not constant space. Let's give that a shot though. So we'll say the middle equal to find middle of linked lists head. Yeah, that takes head. So this is what we wrote in the last video. Middle gives us find middle of linked lists. Then what do I do? So runner 1, R1 is going to equal head. R2 is going to equal middle. Right, because this one returns a node. Yes. Returns a node. And say let middle value equal middle dot value. Okay, so All right, I want to see how they're starting this thing. Oh, it's a problem challenge. If we divide the linked list into two halves, the node values of the first half should be similar to the node values in the second half in the backwards direction. Yes. Yes, we can't move backwards. So to handle this, we'll perform the following steps. Once we have the middle of the linked list, we will reverse the second half. Then we will compare the first half with the reversed second half to see if they're the same. Finally, we will reverse the second half to revert it and bring the linked list back to its... What the heck? So get the middle. The previous equal null. Well, head does not equal null. Head equals head.next. Head.next equals previous. Previous equals head. Head is next. So this is a function to reverse a linked list. Okay. So we reverse it. Okay, because slow is at the middle. Fast is... Oh, so then we copy it. Copy second half. Compare the first and the second half. While head does not equal null and head second half does not equal null. If the values aren't the same, do that, otherwise progress. Okay, well, let's just steal this then. So we have a reverse. They're doing this like, so maybe constant space, yeah, it means like, well, I mean, they're duplicating the linked list. Like, what if I just stored it in an array? Constant space, though. Oh, maybe it's just copying the header and it's not actually making anything new. Okay. Yeah, so... Well, head second half is reverse R2. Copy it. Then if bum 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 oh wow, it's true. While true, while it's true, we say if head second half oh geez, okay, if head second half dot yeah dot value, okay. So if these values are not the same, we return false. Else, if otherwise, if we make it to the end, then we return true. It's true. So we're stuck in a loop. Oh, because we gotta traverse the list, and there's an error. Bum 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 bum. So let's do that instead. Next is false. Excuse me? They're reversing it. Oh. Oh, that's so confusing. Oh yeah, we had to re-reverse it. And if both are null, we return true? Dude, what the heck? Well, let's think. Head second half. Let's go up. Once we have the middle of the linked list, we reverse the second half. Then we compare the first half with the reversed second half to see if the linked list represents a palindrome. Finally, we reverse the second half of the linked list again to revert and bring the linked list back to its original form. Here is what our algorithm will look like. So if we start and either are null, we just return true. I guess that means nothing is there, okay? Find the middle, reverse it, copy it so we can reverse it back. Okay, here's what I don't understand. Head second half is not null, head is not null. We traverse, and we break if it's not a palindrome. Oh, I return false. Wait, but if I return... What happens if I do that? Oh, it does error, okay. So then, if R1 equals null, Yeah, if they both equaled null. Okay, so yeah, if it did escape properly, because we had to reverse this before we unreversed it, we had to like check this exact same thing again. That's why this is here. That's why we have the return true in here. And if not, then we false. So yeah, the constant space, that was the critical keyword here, because we reversed the list in place. So not constant time or whatever, but the algorithm should have O(n) time complexity, where n is the number of nodes. Is that true? O(n), yeah, because I guess n could be infinite, so like, yeah, whatever. Well, there we have it.